Okay, so today we're going to be talking about how to name binary molecular compounds. So far we've only been working on naming ionic compounds, which are combinations of metals with nonmetals or a cation with some sort of polyatomic anion. Well, for molecular compounds, now we're talking about working with combinations of nonmetal to other non metal atoms. So remember, nonmetals exist to the right of the stair-step line. Okay, so these are the things that have high electronegativity. Because both elements are going to have high electronegativity, they're not going to be able to steal electrons from each other to form ions. Instead, this is where we get our molecular compounds overlapping and sharing their electrons, thus being covalently bonded. So the naming here for binary molecular compounds doesn't have as many moving parts as ionic compounds did. For this, we use what's called the prefix system. The prefix system is going to help us to identify how many of each element type are in the compound when we look at the name, which is different than ionic compounds. In naming ionic compounds, writing formulas, there's nothing about the name that indicates how many of the cation or how many of the anion are present. That's different for this type of naming. So as far as naming them goes, the first rule is the first element in the compound. If it only has one atom, we do not add any kind of numeric prefix to the name. If there is more than one, then we will. So we have two examples here. CF4, in that first compound, we have just one single carbon. And so to start the name on this, we would just say carbon. On our other example here, we have N2O3. Well, that first element is nitrogen. But since there's two of them, we're going to be adding the prefix Di to represent the fact that there are two nitrogens in the compound. As far as the prefixes go, you can find a list of the numeric prefixes at the bottom of your notes. So the prefix for 2 is Di, di. All right, so we've taken care of the first part of the name. Step 2, we always add a prefix to the second element of the compound. And so, again, to start things off, we had carbon. And now for the next one, we have fluorine. But there are 4 fluorine in this compound. And so the prefix for 4 is tetra. And so we'll say tetrafluorine for that. In our other example, we already said that the first part of this name is dinitrogen. And now we've got 3 oxygen, and the prefix for 3 is tri, T-R-I, so we've got trioxygen. And then step 3, we change the ending of the second element to IDE. So the first element in our binary molecular compound, we don't change the ending to it. It's always going to stay as is. But the second element, we always change the ending to IDE. So for CF4, the full name for CF4 is carbon tetrafluoride. And for our second compound here, it's dinitrogen trioxide. So there you go. That's how we name those compounds. Now, going in the reverse order, because the names of these binary molecular compounds tell us what the two elements are and how many of each element are present, writing the formulas for the names is a pretty quick process, and we'll get some examples of that in just a second. So our numeric prefixes, 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hecta, 7 hepta, 8 octa, 9 nona, and 10 deca. You might recognize several of those prefixes. They're the same prefixes that we use in geometry for naming polygons. So for instance, a pentagon has 5 sides. There is one other naming convention that comes up from time to time. If the element name starts with a vowel, we will drop the A or the O from the prefix name, but we never drop the I from a prefix. So we have a couple of examples of that in the examples we're going to do here. So we'll take a look at that as it comes up. Okay, so let's take a look at writing some more names based on the formulas. So here we have Si3 and 4. So Si is silicon. And there's 3 of them, so it's going to need a prefix, and the prefix for this is tri. So we've got trisilicon. And then the next one here is nitrogen, so it's going to be nitride, but there's 4 of them, so we need the prefix for 4. So this is going to be tetranitride. Our next example, F2O. So F is fluorine, and since there are 2 of them, we're going to have difluorine. Again, the first element, we never change the ending of the name, so it's just still going to stay fluorine, so difluorine. And now we have oxygen, which is oxide, and we're going to have 1 of them, so it's going to be monoxide. Now here is an example where we have slightly changed the prefix. The prefix for 1 is actually mono, but because oxygen starts with a vowel, instead of saying monoxide, we've dropped off the O from mono and just gone with monoxide. So again, if you have an element that starts with a vowel and your prefix ends with an O or an A, you drop that O or A off of the prefix. For next example, we've got antimony, and there's 4 of them, so this is going to be tetraantimony. And we've got oxygen, so this is going to be oxide, and there's 6 of them. And the prefix is hexa, but again, oxygen starts with a vowel, so we're going to call this hex oxide. And actually, now that I'm looking at our first part here, it should not be tetraantimony, because antimony starts with a vowel. And so I'm going to rewrite this, and it's going to be tetrantimony. That's fun to say. Tetrantimony hexoxide. Okay. Our next example, this one you might recognize, CO2. So why is this called carbon dioxide? Well, there's only 1 carbon, so no prefix needed. And then we've got oxygen, there's 2 of them, dioxide. Again, even though oxygen starts with a vowel, we're not going to drop the I off of the prefix di. Similarly, we would not drop the prefix off of tri. We only drop the A or the O off of the prefix when the element starts with a vowel. And then our last example for writing names, we've got selenium, and there's only 1 of them, so no prefix. And then here we have fluorine, which we're going to change to fluoride, and the prefix for 4 is tetra, so this is tetrafluoride. Okay. Now we're going in the other direction. We're starting with the names. And now here again, because the prefixes in the names tell us about how many of each element we have, these go pretty quickly. So we've got chlorine heptoxide. No prefix on chlorine, which tells me it's just 1 chlorine. Oxide is oxygen. And hept tells me that I have 7. So our formula there is ClO7. Our next example is iodine pentafluoride. Again, no prefix on the iodine, so I know we just have 1. Fluoride tells me I'm dealing with fluorine, and pentafluoride tells me that I have 5 fluorine. So IF5. Next we have diantimony trioxide. So antimony is SB. The prefix di tells me that I have 2 of those. And then trioxide 2O3. Next, we have dicarbon monoxide, so carbon. The prefix di tells me that I have two of those, and then monoxide tells me that I have just one oxygen, C2O on that one. And then our final example is arsenic trihydride. So arsenic, there's no prefix. That tells me it's just going to be AS for arsenic. Trihydride. Hydride, that is hydrogen. And tri tells me that there are three. Okay, so that is how you name binary molecular compounds. Again, binary meaning that all these compounds are going to be made up of two elements. Because they are molecular compounds, they are going to be made up of combinations of nonmetals with nonmetals. And so you're going to be looking for elements over on that right-hand side of the periodic table, along the stair-step line, or to the right of the stair-step line. So there's your examples. You do have an assignment to work on, doing some practice there, and we'll be going over that tomorrow.